lesson, we're going to talk about other types of equations that you've gone over in your Algebra 1 or Algebra 2 courses. There are a few questions we'll do that are quadratics again, so it would be somewhat of a review from the last lesson. But I want to focus on kind of the other types of equations you might see. So we'll start with a general note about rational exponents, and this is where you're going back from a fraction in your exponent and rewriting it as a radical around that number. So I'll give you an example with letter A. All right, the first thing I notice, it is a negative rational exponent. So I'm going to do 1 over 64 to the positive 1/3 power. All right, so everything I do is going to be in the denominator now. So this is going to be 1 over, and here's how you rewrite it. You write a radical, you put the 64, and that denominator, right, this denominator, I'll highlight it, this denominator is what we call the index of the radical. If you wanted to, you could put that cube root of 64 all around, in parentheses, and raise it to the first power, which is the numerator. But you don't need to, right, because raising anything to the first power is just going to be the same. So now I have 1 over the cube root of 64, which is going to be the same as 1 over 4. Let's try using that understanding to help us with letter B. So I see x to the 3/2 power equals 125. Now I want this to be x to the first power. So what I'm going to do is going to actually take both sides and I'm going to raise it to the reciprocal power. So to the 2/3 power. Because you guys learned in 9th grade or probably 8th grade or 10th grade that when you have powers raised to another power, you multiply. And multiplying by reciprocals gives you 1. So this just becomes on the left side x to the first power. Now I'm going to rewrite this as 125 to the 2/3 power and then rewrite it using a radical. So put my radical symbol, that denominator 3 is the index. But now I am going to put it in parentheses because my numerator is not just 1. So hopefully you know the cube root of 125 is 5, and then 5 squared is 25. Let's do part C. All right, very similar process. I'm going to copy it down to give myself some room to get rid of that fractional exponent, or we call a rational exponent. So I'm going to raise everything to the 2/3 power. All right, so that means this just becomes x plus 5 is equal to 8 to the 2/3 power. I'm going to write it as a radical. So put that 8 with an index of 3, so it's a cube root. We are going to square it. The cube root of 8 is 2, and 2 squared is 4. So what makes this true would be -1. All right? Okay, now let's talk about some polynomials. All right? So we're going to use our experience with polynomials from previous classes to help us solve with factoring. In part A, it's going to be pretty straightforward, factoring out a greatest common factor and going from there. And then in part B, we're going to do some greatest common factor to start, but then move into what you've done in the past called factor by grouping. All right, so let's do A first. So I'm going to move the 3x squared to the other side and write minus 3x squared equals 0. We have some common factors here. I see they both can share a 3 as well as an x squared. So that's going to leave me with 4x squared minus 1. All right. Now my 3x squared can't do anything with that, so that's going to kind of just come along for the ride. But if you notice, right, for me, I've got alarm bells going off. 4x squared minus 1 is one of my favorites. It is the difference of two perfect squares. Can I take the square root of 4? Yes. Can I take the square root of x squared? Also yes. Can I take the square root of 1? You betcha. So this becomes 2x minus 1 times 2x plus 1. So now if I set each of these equal to 0, I get x equals 0, right? 0 squared is 0, 0 times 3 is 0. Then this one is going to be positive 1/2, and this last one is going to be negative 1/2. Again, I'm using that pattern I know to change the sign and then put it over that number in front of x. Okay, so I have 3 solutions there. Oh, you might be wondering, just a quick aside here, why we only got 3 solutions when you see x to the 4th power. That's because this answer here came from x squared, which means we call that a double root or double solution. So it's not like you count it twice, but if you were to graph it, it would change the way the graph looks because of that double root. Let's do B. Personally, I'm going to take out the 3. They all have a 3 in common. So I'm going to factor out that 3 to get 3 times x cubed minus 2x squared minus 9x plus 18. Then because of that 3, I just kind of ignore it, and I just focus on this x cubed minus 2x squared minus 9x plus 18. That's all I care about. I'm going to factor that by grouping. So I'm going to group the first 2 together and factor out x squared and get x minus 2. And then the next 2, I can take out a minus 9 and also get x minus 2. So the whole point here is that this is going to only work if when you do this process, if these 2 are the same. If those are not the same, then either you made a mistake or you're unable to do this factor by grouping process. So now you take the things that were in front, the x squared and the minus 9 of those common factors, and you bring that down. And then because they share the x minus 2, you just bring that down. All right, if you want to bring down the 3, you can, but as you hopefully have learned in your other classes, that if there's no variable with that number out front, it is not going to actually create a solution or a root. So there's really no reason to bring it down unless you want to. Another dot scenario of x minus 3, x plus 3 times x minus 2. So I have 3 solutions here, plus or minus, let me get this right, x equals plus or minus 3 and a positive 2. All right, so that's it for the polynomials. Let's move on to radical equations. All right, key thing is here, you want to make sure that the radical is isolated. All right, and in this case, they've already given us one that's isolated. So I'm going to square both sides right away. So I'm going to raise both sides to the second power. And this can be where some mistakes happen if you have not mastered how to expand a binomial squared. So this just becomes x plus 3, right? And here's how you expand it using kind of the quick way, the way that I want you guys to do when you're in college, is you take, let me do a quick work over here and try to show you what I mean. So you take the first term, 3x, and you square it. You take the second term, the minus 1, and you square it. But you also need to add 2 times the first term times the second term. Let me make that a little bit wider there. There we go. All right, so I never write this out. I'm just showing you how I always do this in my head. So that's going to be 3x squared, which is 9x squared. If I were to take negative 1 and square it, that gives me plus 1. And then don't forget the middle term. 3x times negative 1 is negative 3x. Double it, you get negative 6x. All right, I'm going to get everything to one side and set it equal to 0. So that's going to be 9x squared minus 7x minus 2. Now, at this point, right, I see I have a quadratic trinomial that I'm going to try to use my strategies from last lesson, which is first factoring. And because a is 1, I'm going to do the slide, divide, bottoms up method. So I'm going to move that 9 over, right? So slide it over to get 9 times negative 2, which is negative 18. Let's see if we can factor this. So x and x. Factors of negative 18 to add to negative 7, that's going to be negative 9 and positive 2. Yes, that works. Put those over that number you slid. So I get x minus 1 and 9x plus 2. All right. Don't forget to solve both of these. You get 1. And because I know that, that trick, I do the opposite of 2, which is negative 2 over that a value of 9. Now, just to be clear, whenever you are solving pretty much any equation, you should do this, but for sure, definitely if you see a radical symbol, you want to always check to see if this is going to be okay, all right? So if I plug in 1, right, I get 1 plus 3. So when I say plug in, I'm talking about to the original, right, all the way back up here. 1 plus 3 is 4. The square root of that is 2. 3 times 1 is 3. 3 minus 1 is 2. So this works, right? 1 checks out. I need to check it. And I could plug in negative 2 nines, go through it, show you on Desmos, or just do it by hand. But the moment I plug that in, I notice negative 2 nines plus 3. All right, that's still going to be a positive, so that's okay. But if you look on the right side, 3 times negative 2 nines, right, that's going to be a negative, minus another negative, that's still negative. And when you take the square root of a number, it will never give you a negative. So I'm going to cross this out. and we call this an extraneous solution. But I want to make sure you understand why I crossed it out. I did not, I repeat, I did not cross this out because it was negative 2/9. I crossed it out because when I plugged it in, I got a negative on the right-hand side, and I can never get that taking a square root. So just be careful when you're like, oh, it's negative, it can't be right. That's not always the case. All right, let's go to absolute value. I'm going to stick with absolute value equalities for this lesson. And very similar to what you did on the radicals, you're going to isolate the absolute value. And once you have it isolated, you're going to have two equations from there. You're going to write one that's equal to that number, so literally copy it, but just drop the absolute value symbol. Or you're going to set the equation equal to the opposite of that number. So let me show you in example A. So I'm going to do 1 minus 4x is still in there. 13 minus 8 is 5. So this is isolated. So now I set up two of them. 1 minus 4x, make sure you think that's a 1. 1 minus 4x equals 5. Or 1 minus 4x equals negative 5. Because if that's true, when I take the absolute value of it, I will get a positive. So that's why you have two possibilities for answers here. So negative 4x equals 5 minus 1, which is 4. Or negative 4x equals negative 5 minus 1, which is negative 6. You get x equals negative 1. Or, do some simplifying here, positive 3/2. Okay? Again, you always want to check, but in this case, I'm not really worried about checking, because if I plug these into the absolute value, I still am going to get 5 once I take the absolute value. So no issues there. Now let's do letter B. All right, let's isolate it. So 2x plus 1 equals negative 3 plus 2, which is going to be a negative 1. All right, now, a lot of times if you've done this, I know you did this in Algebra 2, what you'll do is you'll set everything up, you'll get all answers, you'll be like, great, and then you'll turn it in, your teacher will be like, no, this is incorrect. And the reason is because this moment, right, at this moment that I look at this, you just take a moment to analyze this, you have the absolute value of 2x plus 1. So no matter what you plug in, you multiply by 2, you add 1, take the absolute value. These will be always positive, right? Always positive numbers. Will that ever equal a negative 1? And the answer is no. You'll never be able to plug in a number that when you take the absolute value of it at the end will ever give you a negative. So there are no real numbers, so no solutions that would work for this one. Save yourself some time. All right, I told you there'd be some quadratics. All right, just a little bit, that's the same, but I'm going to tweak it a little bit to make it a little tougher, so it's not something you've seen in the last lesson. This one looks like you need to do a lot more complicated work, but really, if you notice this is fourth power, then squared, then constant, you could actually just use your understanding of basic factoring, but just make these x squared, okay? So factors of negative 9 that add to negative 8 would be minus 9 and plus 1. And I've got dots here. So I've got x minus 3, x plus 3. All right, and this one is not a thing. I've had students try to factor x squared plus 1 before, right? I always tell them SOTS, or the sum of two squares, is not a thing, even if it sounds fun to say. So I've got some solutions here, x equals plus or minus 3 for those two. And then if I were to take the time to solve this one, you move that 1 to the other side, you get negative 1. Taking the square root of both sides, you'll notice something you talked about in Algebra 2, that this is x equals plus or minus I, right? Because the square root of negative 1 is what you learned as the basic imaginary number. All right, so you have 4 solutions, but you only have 2 real. So you got 2 real solutions, right? Plus or minus 3, and you got 2 imaginary solutions, plus or minus I. All right, let's try letter B. What they want you to do for this one is they want you to imagine with some u substitution that u is x minus 5. So I can rewrite this as u squared minus 4u minus 21. So now if we factor it, right, it becomes way simpler. I'm going to use 7 and 3, so u minus 7 and u plus 3. Okay? Now if I were to just be dealing with u's, I've had u equals 7 and u equals negative 3. But this whole thing started, right, letter B started with they included x. So now if I go back to my substitution here, right, and u is the same as x minus 5, I can replace this as x minus 5 equals 7, and x minus 5 equals negative 3. So I get x equals 12, or x equals C2. All right. So it's still quadratic, something you've seen before, but a little bit of a change up to what we did last lesson. All right, so let's keep going. All right, we got one more here. We're trying to solve a rational equation. So you'll notice we have fractions with the variable in the denominator. All right, and the way that I used to teach students in Algebra 2, and hopefully the way you were taught, was if you factor this denominator here, it becomes x times x minus 2. So if I multiply, right, and when I say this, just the tops, so just tops by x times x minus 2, the purpose of doing that is I will literally eliminate all of my denominators. So I'll rewrite this with some space because I got a lot of room here. So I'm going to do 3x plus 2 over x minus 2 plus 1 over x equals negative 2 over, and I'm going to write the factored version. Okay, so here's what I mean. Let me show you the process. So if I were to multiply all three of these, so this one by x times x minus 2, this one times x minus 2, and the last one, when I do this, right, when you multiply fractions, you can cross out by looking diagonally. So I could actually cross out this x minus 2 with that x minus 2, this x with this x, and for this last piece, I could cross out the entire denominator. So now, when I bring everything down, I don't have any more denominators. So this is x times 3x plus 2 plus 1 times x minus 2 equals just negative 2. So it makes this a much simpler equation now. Let's distribute. You get 3x squared plus 2x plus x minus 2 equals negative 2. Get everything to one side, just set it equal to 0. So 3x squared plus 3x. And then if you were to move that minus 2 over with addition, you actually get 0. So it's just this. Let's do some factoring. So I factor out the 3x, get x plus 1. So I have x equals 0 or x equals negative 1. Now, before you move on and say we're all done, don't forget we got all of this from this rational equation at the top. And when you have variables in the denominator, you have to be cautious. So if I were to plug in 0, no issues with the first fraction, but look at this second fraction. If I plug in 0, I get 1 over 0. That's a problem. So kind of like before, this is not a solution. We call this an extraneous solution. All right. When I check out negative 1, don't see any issues there. I can have negatives in the bottom. That's not a problem. Not going to make 0. So we should be good there. All right. So that's it for this. Make sure to try some of the practice problems.